Hello, I'm Rob Higuerita. I'm an enterprise support lead at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Luis Fox and Ketan Kumar from AWS Support. Can you give us a quick introduction, Luis, and then Ketan?
Sure, thanks, Rob. Hi, everyone. My name is Louise, and I'm a technical account manager based in Amsterdam, the Netherlands. I used to work on the security team in support, and now I work with enterprise customers, helping them with their DDoS resilient architecture.
Hello, everyone. My name is Ketan Kumar. I'm a technical account manager based in Dublin, Ireland. I work with enterprise customers to help them secure their applications and build resilient architectures in the AWS cloud.
Thank you both. Today, we'll be introducing you to how you can architect for DDoS resiliency in AWS. We'll specifically focus on how you can use AWS Services to help and what options you have with AWS Support as well. Before we get into the details of today's episode, a quick note to the attendees online. Please feel free to use the chat window on the right-hand side of your screen there to share your thoughts and ask questions throughout the episode. We've got both Ketan and Luis here to answer your questions, so we really look forward to hearing from you. Luis, can you walk us through what we're going to be talking about today?
Yeah, sure. Thanks, Rob. So the agenda for today is what is DDoS? So distributed denial of service attacks. We'll be going through different types of threats based on the OSI model and different common security risks as well. The different AWS services that you can avail of, we'll be going through each of these and their security features and how you can use those to help architect for DDoS resiliency. We'll also be going through monitoring, logging, and alarms and the different services and features we have here, the benefits of AWS support from myself and Ketan, and lastly, a summary and best practices. So getting started, what is DDoS? So firstly, we're going to have to start with what is DOS, so denial of service. This is a deliberate and malicious attempt to make your website or application unavailable to users by basically flooding it with network traffic. So to achieve this, attackers would use a variety of different techniques that consume large amounts of network bandwidth, or else they might just even tie up system resources, and this will disrupt access for legitimate users. So in its simplest form, as you can see here in the diagram, there's one attacker, the computer there on the left, and it uses a single source to execute a DOS attack against the target. So that's what that is. And then moving on to DDoS attacks, so distributed denial of service. This is basically an attacker using multiple sources, such as distributed groups of malware-infected computers or routers or IoT devices to basically orchestrate an attack against a target. So as you can see here in this diagram, it's using bots, so several different bot computers against a target to basically overwhelm or flood the network resources on the target. So we can distinguish DDoS attacks based on which layer of the OSI model they attack. The most common layers are 3 and 4, so network and transport layer, and these are known as infrastructure attacks. And also presentation and application layer, so layer 6 and layer 7 attacks, and these are known as application layer attacks. So Ketan will be going into more detail on those in the next few slides. And here is a graph we have on growth of volumetric attacks. So as networking technologies advance over time, we also notice a massive increase in the size and throughput of attacks against our infrastructure. So there has been spikes, as you can see here, in 2016, 2018, and 2020 for all new attacks. And you can see the spike actually drops after we find a way to either remediate the attack or just become better at dealing with it. But unfortunately, new attacks always do arise. And the whole point of us even adding in this graph is just basically to show you that it's more important than ever to consider building out a DDoS resilient architecture to mitigate any risks. And AWS can enable you to plan for DDoS resiliency in your architecture and avail of our different services, which we'll be going into more detail in this presentation. So Ketan is going to carry on with different types of threats.
Thanks, Louise. So I'd like to cover some of the common threats that applications experience today. So we can categorize these attacks based on the different levels of the OSI or the open system interconnection that Louise was mentioning about. So starting at the bottom, so the AWS organization operates the cables, the switches, and other networking devices. So we take complete responsibility of that. So going up one level, we see the network layer attacks. So we see ping of death or ICMP flood attacks or the teardrop attacks. So these are attacks that are orchestrated by sending large packets to the target or overlapping packets. So the target exhausts its resources trying to stitch all those packets together. Now going up one more level, we see the transport layer attacks. So these are attacks that leverage the TCP and UDP functions to launch attacks. So we have some dedicated talking points on this coming up, so we'll talk about them then. And moving up one more level, we see the top layer attacks. That's the application layer. So we see various application-specific DDoS attacks. So commonly, we see volumetric attacks like HTTP floods and non-volumetric attacks like SQL injection or SSL abuse attacks. Now, if you look at these attacks through a different lens, we see the security risks that they cause to your applications. So some of the most common ones are application layer vulnerabilities, bad bots, and DDoS attacks. Sometimes these attacks happen at the same time. So you are distracted by the DDoS attack, but at the same time, some intelligent attacks will be taking place towards your database or application servers. So we have SQL injection attacks, where attackers use malicious SQL code for backend database manipulations. We have cross-site scripting attacks, where malicious scripts are injected into trusted websites. We have OWASP and CVE, which provides you a list of best practices and security flaws in various softwares. We then have bad bots, where they attempt to scrape content from your website, like web assets or catalog pages. For example, you have pricing pages, product image pages, or just information behind a paywall. Now let's look at how the UDP reflection attacks are performed at a high level. So this is one of the common attacks that we see year over year. So these are UDP-based reflection attacks. So there are three entities here: the attacker on the left, the reflector in the middle, and the target server on the right. So the attacker sends a request to the reflector server, but replaces its own IP with the target's IP address. So when the reflector sees the request, it believes that the request was made by the target server on the right, as the IP was spoofed. Now, UDP responses from these reflector servers would tend to be larger in size compared to the request. So if the reflector was, let's say, a DNS server, we would see an amplification of about 28 to 54 times. So to put that into perspective, if you look at an example, if the request was, say, 64 bytes, we would see a response of 3,400 bytes. Now imagine an attacker leverages thousands of reflectors to increase the scale or the volume of the attack. This could be quite detrimental to your server. Now let's have a look at the SYN flood attacks. So on the left-hand side, you see the typical three-way handshake, where clients send SYN packets to the server to initiate a connection. If the port is open and the server is ready to take those connections, the server responds with a SYN ACK flag enabled in that response. And the client then acknowledges this by sending a response with the ACK flag set to true. So at this point, you can say the connection is established. Now let's have a look at how attackers can take advantage of this, right? So the attacker would only send a SYN packet in the request. The server would then reply with a SYN ACK, just like how we saw previously. At this time, the server is dedicating all its resources and buffers waiting for that third acknowledgement. But the acknowledgement is never sent. So by doing this, the attacker will successfully ensure that the server fills up all its buffers. Another form of this attack would be when the attacker only sends acknowledgement packets to the target. The target tries to match those acknowledgements to previous SYN packets, but the SYN packets were never sent. The server begins to exhaust its resources, thereby causing an ACK flood attack. Now we look at application level attacks, primarily around web applications. So these are attacks targeted at layer 7 of the OSI stack to overload specific functions that becomes unresponsive to your legitimate users. So in an HTTP flood attack, an attacker sends HTTP requests that appear to be real. They try to imitate human interactions. Then we have cache busting attacks. So web applications, as you all know, now have content delivery networks in front of them. So they cache your responses. Now, CDNs would cache those responses based on different parameters in the incoming request, like query string or certain headers. the attacker makes variations to that query string to circumvent those CDN caching services. So instead of being able to return a cached result, the CDN must forward that request to the origin, thereby causing a strain on the origin server. This could take place over DNS as well. So you send random strings to bypass that cache. So at this point, I'll pause here and check with Rob if there are any questions.
Hey, Kate, thanks. Yeah, we don't have any questions right now, so just a reminder to the audience, please make sure to post your questions in chat. We've got Luis and Kate here to help answer them, so take advantage of their time. Back over to y'all.
Thank you.
Thanks, Rob. So now we want to introduce you to some of the AWS services and tie them together and create a DDoS resilient architecture. So let's start off with Route 53. So this is our highly available and scalable domain name service. So we have a global footprint of DNS servers placed around the globe, operated and managed by AWS. So this is built under the underlying concept called Anycast. So Anycast is not specific to AWS, but it's a routing mechanism where you'd be able to advertise the same IP address from multiple locations. So this allows us to abstract away from that specific IP address to provide responses. So it also uses techniques like shuffle sharding and Anycast striping. So that can help users access your application even if the DNS service is undergoing a DDoS attack. The service also checks for anomalies in the source and the volume of the DNS queries. So this allows us to identify reliable sources and prioritize those sources. By doing this, we're absorbing those DNS floods. You can take this one step further by setting up routing policies on Route 53 with the use of health checks. So for example, if you see a certain application is down, you can use Route 53 to start directing your traffic to another region or a disaster recovery setup. Apart from this, you have other functions like domain registration, where you can purchase domains. You have health checking. You also have hybrid DNS setup between your on-premise and the cloud. Next, we'll move on to an introduction of the AWS Web Application Firewall. So we see customers delivering their web applications today with Amazon CloudFront, Amazon API Gateways, REST API, application load balancers, or GraphQL with AppSync. So today, you'll be able to integrate these services with AWS WAF without any changes to your application code. So the way the architecture is set up is in such a way that the firewall inspects your traffic and sends clean traffic back to your application. So we try to send clean traffic to you. So the way you can inspect this traffic is by using custom rules that you build, or you can leverage the pre-configured rules that the WAF solution provides to you. So within this service, what you have is what we call the rate-based rules. So this allows you to inspect traffic and create a rate-based rule for them. So in the sense, you block IP addresses if it crosses a particular threshold. And all of this is done in a single millisecond latency. Apart from this, you can also leverage the WAF geo-IP database, so block requests from certain countries that you do not do business with. You can configure the service to block requests with customized responses instead of that error that you get with the 403 forbidden. So by doing this, you prevent attackers from changing their strategy of their attacks. And finally, you also can leverage marketplace rules created by third parties that we have partnered with, and you can leverage them in this firewall architecture. Next, we move on to effectively scaling your EC2 instances within the virtual private cloud, or VPC. So we know large DDoS attacks can overwhelm the capacity of your Amazon EC2 instances. So adding a load balancing service in front of it helps with resiliency. So the Amazon Elastic Load Balancing Service is designed specifically to scale up based on different traffic patterns. So we can scale and handle millions of requests per second. And additionally, we can route traffic to healthy backend instances that you have set up. So based on the SYN flood attacks, the ACK floods that I mentioned earlier, so this service is able to absorb all of that and only send properly formed TCP handshakes back to your application. Additionally, the load balancer, which is an application load balancer, it only listens on HTTP and HTTPS. So by default, you're protecting yourself from those UDP floods that I mentioned earlier as well. Then, as you can see there, the backends of the load balancer could either be EC2 servers, containers, Lambda functions, or even IP addresses. So you have quite a lot of flexibility there. So we also recommend customers to scale up based on request patterns. So you can do this today by leveraging the AWS auto scaling service. So what this service does is based on certain criteria that you set up. So for example, you have CPU utilization or network traffic. If that metric increases above a particular threshold, auto scaling then adds instances into the auto scaling group just behind the load balancer. And additionally, I mentioned the load balancer does health checking to the backend instances. So it knows which backend to forward the traffic to. We also recommend customers to reduce their attack surface by using services like our security groups and network access lists. So by doing this, you're only allowing traffic on certain ports and protocols. All right. So now I'll pass the mic on to Louise to introduce you to Amazon CloudFront. Louise, I think you might be on mute.
Sorry, I was on mute. So CloudFront is our content delivery network service, our CDN service that securely delivers content globally. And basically what CloudFront does is it caches your content at the edge location all over the globe, and you can leverage CloudFront to build availability protection against all known infrastructure layer attacks, making it even more resilient. So it has a stateless SYN flood mitigation technique that basically proxies and verifies any incoming connections. So for example, it would verify three-way handshake connections before passing any traffic back to the application in the origin. And what this does is by verifying the connection, it will be preventing any DDoS attacks such as SYN flood attacks or UDP reflection attacks from reaching your origins. So making it, again, just another level of security, basically. And lastly, it can be combined, CloudFront can be integrated or combined with Web Application Firewall, WAF. And by doing this, there is an additional layer of application layer defense because you can create web ACL rules, and then you can add these to your distribution, and this can block, allow, or count any incoming requests to your distribution without having to change any of your current application architecture. So yeah, it's pretty cool. And on the next slide, you're going to see API Gateway as well. So this basically acts as a front door for any applications to access data, business logic, or functionality from your backend services. And what this does is it secures your APIs on the front end, which reduces the risk of being targeted by a DDoS attack. So basically following our best practices of reducing your surface area is what that's doing, because it's going to be securing your APIs and ensuring that that basically your surface area is reduced. Then as well, another mitigation best practice we have is scaling to absorb any excess traffic, ensuring that your application stays up without any issues during any possible attack. So what API Gateway can do here is it can scale to absorb application layer traffic, making your infrastructure more resilient and being able to hold up with any excess traffic. And then lastly, it protects your backend from any excess traffic as well by configuring rate limits for your REST APIs. So what you can do here is you can set a number for the rate API, and it will be able to actually count that number, and then it can block any additional traffic as well. So last but not least, so Shield is our managed threat protection service. And Shield, just in general, there are two types, Shield Standard and Shield Advanced, which I'll get to in a minute. But basically, the features of Shield is that it's easy to configure without changing your application architecture, report and access to the DDoS response team. So this is a team of experts that are placed globally around the world and can help you with any of your sophisticated security questions or architecture questions, or they're also there to help you during times of attacks as well. Customized protection based on your unique application characteristics, and lastly, protection from economic attack vectors. So just diving a bit more into Shield again, the benefits of Shield Standard and Shield Advanced. So AWS provides two levels of protection against DDoS attacks. So Shield Standard is applied automatically to all AWS accounts at no additional charge, so all AWS customers can benefit from this. And what it does is it defends against the most common, frequently occurring network and transport layer attacks, so 3 and 4, that target your website or application. So Shield Standard helps protect all AWS customers. But if you want to get even more of a benefit out of it, we really recommend also using CloudFront and Route 53, the two services we touched on earlier, because these provide even more availability protection against infrastructure attacks, so layer 3 and layer 4 attacks as well. Then you also have Shield Advanced. So this is for a higher level of protection against attacks, and you need to manually subscribe to this, and there is a cost to it as well. And what you can do is you can add specific resources to be protected. So this has a few additional features. We're going to touch on Shield Standard first. So it has pre-configured layer 3 and layer 4 protection, which I mentioned, and DDoS threat environment dashboard. So this is available as well to Shield Standard and Shield Advanced customers. We're going to go into more detail on this and show a diagram in the monitoring and logging section. But this is a great feature, and it can show all of the active and previous DDoS attacks globally. Then the green boxes here are just for the Shield Advanced benefits, which I'm going to go into now. So faster mitigation, CloudWatch event notifications. So there are custom CloudWatch metrics that are just for Shield Advanced, and these detect DDoS attacks and things like that. And you can be notified of these through alarms as well. So customized layer 3 to layer 7 protection, so all the way up to the application layer of the OSI model, Shield Advanced protects and mitigates against those types of attacks. And as I mentioned before, 24/7 access to the Shield response team. So this is just a team of experts basically that ensures that your AWS services are up and running every day, and you can leverage that expertise to help with any application security challenges that you might face. This team is distributed globally, so there's always someone available in your time zone as well to help you. And going to the next slide, there's several more benefits. Here they are. So L7 anomaly detection, so anything that seems different to your normal behavior. Proactive event response. So Ketan mentioned this earlier with the Route 53 health checks. So this is a proactive event response. Adaptive layer 3 to layer 4 protection, and lastly, health-based detection as well. So that's health checks and being informed of those. And here are the services that you can integrate with Shield as well. So you have Elastic Load Balancing, CloudFront, Route 53, Global Accelerator, and EC2 Elastic IP addresses. And what you can do is you can add these resources to be protected. And there's also cost advantages as well. So if you do have an attack, you can actually, with Shield Advanced customers, you can actually save that money and have it scaled up and things like that for you too. So Rob is going to put in a link to Shield and Shield Advanced and the differences there into the group chat for you to see. Moving on to architecting web applications for better DDoS resiliency. I'll pass the mic over to Ketan.
Right. Thanks, Louise. So as we can see there, right, DDoS attacks are common. So how can you prepare yourself to not be impacted by these? So one thing to keep in mind when architecting your environment would be to leverage multiple layers of a defense strategy. So let's start off with Route 53. So we have end users making requests to Amazon Route 53 to resolve their domains. This would serve the DNS responses and at the same time absorb that DNS DDoS attack. Now, let's say the Route 53 service returns an IP address, which is an IP from our Amazon CloudFront CDN range. This allows you to cache your content and also block TCP and UDP floods. But at the same time, you have another layer of defense in the form of AWS WAF. So this inspects your request for malicious content, regulates the rate at which these requests are coming in from your various clients. Now, after these layers of filtering, you would then forward your traffic to either API Gateway or Elastic Load Balancing service. So you can enable AWS WAF on these two services as well and protect yourself from direct to origin attacks. So you also have a way of setting this up so that only CloudFront is allowed to make requests to these services. Then you finally have your application server running in an auto-scaling group. So using security groups and network access lists, you're blocking unwanted traffic based on ports and protocols. You additionally would also want to set up your servers if they require internet access, set them up in a public subnet. But if they don't require any kind of internet access, you put them in a private subnet. So effectively, you have your load balancer in the public subnet and the backend instances in a private subnet. Yep, at this point, I'll probably pause to check with Rob if there are any questions.
Hi, yes, we do have a couple questions from the audience that came in while you're all chatting, sharing some great info. One of them was coming in from the spec 007, kind of wondering to see how would you monitor CloudFront? Would you be willing to take that one?
Yeah, we're actually just about to touch on that in the next section, but just to go into it briefly. So CloudFront actually has its own monitoring, it's standard logging. So you can, it's free of charge actually, you only pay for the storage, and it will log different requests made to your user requests made to your distribution and include timestamps, IP addresses, things like that. And there's also real-time logging as well. So we have, it's Kinesis does the real-time logging. There is a cost to that, but if you do want basically up to the second, you can get that type of logging as well for all requests made to your distribution. We do actually have another YouTube video on this that we just did 2 weeks ago, so I'd suggest checking that out as well.
Great, thanks, Louise. We'd also have another question from Ray_DB222. Are all these protection services HIPAA compliant?
Yeah, I can take that one. So our services, we do have a page where all our compliance services are mentioned. So you can also leverage the AWS Artifact solution where you have all the documentation for all these different services across all the different compliances that we support. And HIPAA is definitely one of them.
Just to add to that, so I've added in the services and scope documentation just now into the comments for you as well. And having checked that, all of the service that we've mentioned so far in this presentation are all HIPAA compliant, but just going by the shared responsibility model. So it's your job as well to make sure that they're HIPAA compliant too. So I'd suggest reading up on that.
Great, thank you both. Back over to you.
Right, so monitoring and logging. So monitoring is an important part of maintaining the reliability, availability, and performance of your services. So as you start monitoring these services, you should create, or you can create a monitoring plan where you should be able to ask yourself questions like, what are your monitoring goals? What resources will you monitor? How often will you monitor these resources? And who should be notified when something goes wrong? Should they be paged? Should there be alarms in place? And then once you have decided this, the next step is to establish a baseline for normal performance in your environment. So you can do this by measuring performance at various times under different load conditions. For example, monitoring WAF and Shield Advanced and the other related services, you can store historical monitoring data in S3, for example, and you can compare this data with your current performance data and then identify normal performance patterns, we'll say, and different anomalies as well. And from here, you can then address these issues. So for example, with WAF, to establish a baseline, you could monitor the number of allowed web requests and the number of blocked web requests. Sorry. So just delving into the services here, we have WAF, Web Application Firewall, which Ketan mentioned earlier. So this monitors web traffic on layer 7, the application layer. We also have VPC flow logs here. So this monitors IP traffic going to and from the network interfaces in the VPC, and it can help in monitoring the traffic basically or troubleshooting any network connectivity issues maybe. GuardDuty, I'm going to be going into more detail on this in one of the use cases, but this is our managed threat detection service, and it can give you different findings on different types of brute force attacks possibly, or denial of service attacks as well. CloudWatch, so this is for monitoring metrics. I'll also be going into more detail on this in a use case as well. Amazon CloudFront, I just touched on that in the answer, but basically this is for monitoring user requests, and there's standard logging and there's also real-time logging as well with Kinesis. And Amazon Inspector, so this checks for vulnerabilities on your EC2 servers as well, and making sure that everything is up to date and all of your right patches are in place. So starting on the use cases here. So GuardDuty findings. So GuardDuty is our threat detection service, and it continuously monitors for any malicious activity or any unauthorized behavior to protect your AWS accounts, workloads, and data. So it analyzes billions of events across multiple data sources such as CloudTrail, which logs for API calls, VPC flow logs, which I mentioned earlier is for monitoring IP traffic, and DNS logs as well. And as you can see here, these are the findings that are most relevant to our presentation today. So the first set of them is denial of service. findings, and these are all found from the VPC flow logs as the data source. So just for example, the first one here, the resource is EC2 and the resource type is an instance. And this finding informs you that the listed EC2 instance within your AWS environment is generating a large amount of outbound DNS traffic, which may indicate that your instance is possibly compromised or being used to perform a DDoS attack using the DNS protocol. So what you have to do then whenever you receive this finding is decide if it's a false positive or false negative, or if it possibly is actually performing a DDoS attack, or maybe it's been affected, then it will also give you steps on how to remediate this as well. So the other findings there are for different protocols too. And then the second one here, unauthorized access. Oh, so this is for brute force attacks. So again, this is from the VPC flow logs. And what this does is it will tell you if or inform you if your EC2 instance was the target of a brute force attack, or if it's being used to perform a brute force attack. So it's either a target or performing it. So again, you can take a look at this yourself. It will give you all of the information, the IP address, timestamps, location, the resource IDs necessary to investigate this. And you can decide yourself if it needs to be remediated, or you can also contact support who can help you with this as well. Amazon, back to GuardDuty, yeah, sorry. So just more on detail with the brute force attack finding I just mentioned. So GuardDuty will be detecting the finding, and then it will send this information to CloudWatch, which will be able to then create an event and report this. And from there, you can actually set up any custom action. So here are some targets. There's Lambda, there's Kinesis. You can be notified through SNS or SES as well, things like that. So yeah, that's how GuardDuty works. And next, moving on to different visibility metrics. So these are metrics over lots of different services here. So we have Shield Advanced, which is DDoS detected and DDoS attack requests per second. So this is for Shield Advanced customers only. Yeah, basically it'll be able to tell you about any DDoS attacks. And then the other ones here for the specific services as well. So you don't need Shield Advanced to be able to avail of the rest of these metrics. But yeah, so basically the whole point of visibility metrics is that when an operational metric deviates substantially from the expected value, this may possibly be an attack. So this is what I was mentioning earlier about if you know your normal behavior of your application, then you'll very quickly be able to notice if there's an anomaly and you'll be able to take action. So that's what these metrics are here for as well. By using CloudWatch, which is what's monitoring these metrics, you can monitor any of your applications running on AWS, collect this data, track these metrics, set alarms, and you can also automatically respond to any changes as well. So as I mentioned, the first one is for Shield Advanced, and the rest as well, you can take use of without having Shield. Yeah. You can also integrate CloudWatch with your own tools or third parties like Slack or PagerDuty as well. So that's what we're seeing here now with CloudWatch alarms. So you have your metric and you can set a single metric, you can set a time period, and you can set thresholds as well, depending on your use case and what you want to get out of this. And then CloudWatch will watch that single metric over a period of time that you specify. And if the value of the metric goes over or under the given threshold that you specified, it can take action. So using, as you can see here, lots of different options. You have simple notification service, which can notify you with email, SNS, or it can actually send an event notification to Lambda, which can carry out some custom action on your behalf. Or as you can see here, it can filter the logs further depending on what you'd like to see in those logs, and it can contact SES to email those logs as well. So moving on to this slide here, this I mentioned earlier when I was talking about the Shield benefits. So this is our global threat environment dashboard, and it displays a summary of the global threat environment automatically updated in near real time. So it's quite a cool feature. It's actually very new as well, and you can see this on the console. So it includes the largest attacks, the top vectors, and the relative number of significant attacks as well. And you can also view time durations as well. So you can see there on the right You can see a history of different DDoS attacks, whether it's last day, last 3 days, or in this diagram screenshot we have last 2 weeks. Yeah, it's really cool. It gives you also the current threat level as well, which is an indicator of the severity of DDoS threats currently occurring on CloudFront, Elastic Load Balancing, and Route 53. And basically, it gives you a really good overview of the DDoS attacks happening today worldwide, and this can help you architect better and learn from these too. Passing the mic over to Ketan to talk about WAF.
Yep, thanks, Louise. So we spoke a little bit about bot mitigation, right? So with respect to bot mitigation, what should your strategy be like? So first, you need to identify which bots you actually want to do business with. So there are good bots and then there are bad bots. The bad bots generally don't comply to certain rules, so they have some adverse effects to your environment. We have, within the AWS WAF service, we have certain set of rules that we provide to you. So you have IP reputation lists. So it looks at scoring across different IPs and block those IPs from the very first request. We have anonymous IP lists. So there's a list of IPs who are trying to hide their location, etc. So you have Tor exit nodes and VPNs, etc. And finally, we have our latest release, which is the bot control list. So you can use this, and it has fingerprints across different bot attacks. And you can leverage this in front of your application. We actually take this one step further. We provide you a CloudFormation template. If you're not familiar with CloudFormation, it's essentially code that you can write in JSON and YAML. It's essentially infrastructure as code. So we provide this setup to you. And then I think Rob could probably send you a link there in the chat. So essentially what you can do with this is you can get some control over how you utilize the WAF logs that Louise mentioned earlier. So it provides you a level of intelligence on how you can manipulate the logs and then use that intelligence into your WAF. So for example, you have rate-based rules that come built in with the WAF service. You can additionally use Lambda or Athena-based queries to perform those rate-based rules. So you have some flexibility there in adjusting them. Additionally, you can also use a concept called honeypots. So with this, you'll have access to a link which you can embed into your web page. And this would be invisible to humans when they go through the web page. But bots, which are actually scanning your website, they identify this link and they try to access them. Just by the sheer idea that they have accessed them, we know that it was a bot. So just by accessing them, there's an API gateway that picks up the IP address and adds that into your web application firewall and blocking that IP address. You also get control over how frequently or how long you want to block that IP as well. Finally, you can also use our third-party IP reputation list from, for example, Spamhaus. You can use a list of that inside your web application firewall. We have CloudWatch events, which trigger that and add that to your web application firewall. Now we want to finally introduce you to the Firewall Manager service. So this allows you to bring all of these services together. So if you have an AWS account, you probably know that these are virtually separated across multiple customers. So in a way, it's sort of like a wrapper around your entire environment. And this provides a certain level of protection as well. So customers today are leveraging this across multiple accounts to reduce that blast radius of attacks, right? Try to keep that in a central location. So with this approach, you inevitably would have to manage firewalls across multiple accounts in your AWS organization. So this is where the Firewall Manager service clearly fits in. So you see on the slide there, you have various services that you currently can use within Firewall Manager. You essentially can create what we call a Firewall Manager policy. And within that policy, you mention the various accounts that you want to add into that policy. And then that particular service gets pushed to all those different accounts. And also, you can integrate Firewall Manager with Security Hub. So Security Hub is another service which allows you or gives you a single pane of glass for all your alerts, findings, and compliance checks. So it aggregates all of these across your organization. So probably at this point, we'll just check with Rob if there are any other questions.
Hi, yes, we do have a couple questions here from the audience. First one, basically just going to ask from Princeton Girl 21, are any of these logging services free of charge?
this is the logging and monitoring slide, is it back? Would you mind going back a few slides actually, just so I can see it?
Yeah, sure. Okay.
Okay, here we go. So I know that CloudFront metrics are definitely free of charge. You just pay for the storage. And I believe it's this, Ketan, you can tell me if I'm wrong. I believe it's the same as well for VPC flow logs, and you just pay for the storage again as well. And then there is a cost to CloudWatch, but I know that there is a free tier. And the free tier, I just looked this up here, it includes basic monitoring metrics, so metrics coming in at a 5-minute frequency, and then 10 detailed monitoring metrics at a 1-minute frequency, and then 1 million API requests as well, and 10 alarms. There's a few other things as well. I'll add the link in now. And then for GuardDuty and Inspector, I know that there is free trials. So that could be worth taking avail of as well. So for GuardDuty, there's a 30-day free trial, no cost in each supported region, and you have the full feature set and detections as well. And then WAF, I'm not sure of. Do you know, Ketan, about WAF?
Yeah, so with WAF, actually, there's no charge for enabling the service, but you do pay the cost for the storage of those logs. And additionally, you pay for Kinesis Firehose, which is our streaming service. So essentially what happens is WAF sends these logs through your Kinesis Firehose stream. So you pay for Kinesis streams there, and then it pushes those logs to various storage locations. So you can choose either S3 or any third-party service that Kinesis Firehose supports. So essentially, those are the charges that you pay. In terms of VPC flow logs, you don't have a fee for enabling them, but in terms of storage, there are some costs, which I think Louis sent the link for already.
Yeah. That has reminded me as well. So also for CloudFront real-time metrics, what Ketan said as well about Kinesis, the same cost applies as well for CloudFront real-time metrics. But if you are interested in monitoring logging and doing it as cost-effective as possible, we also have CloudTrail, which logs API calls to your account. And that is free of charge for seeing the last few logs of 90 days in event history as well. So that might be worth something to look into too.
Great, thanks for going in detail about the different offerings and their logging and cost that went along with that. So I'll send it back over to y'all.
Okay.
Great. So moving on to benefits of AWS support. So myself and Ketan actually used to both work in support for 4 years, myself on the security team and Ketan on the networking team. So we thought we'd just put together a slide on kind of just tips for whenever you open up a case with support in a times of crisis or production pain or DDoS attacks. So we have a follow the sun model where it's 24/7 support, 365 days a year. So there will always be someone somewhere to help you with your question or issue, and you can contact them using the console or support APIs. So if your query is urgent and you'd like to speak to an engineer as quickly as possible, we'd recommend initiating a live call or chat with support. And by doing this, you'll be put through to someone directly and you can talk to them back and forth. And also, if you're in any production pain or a DDoS attack or anything like that happening, we really recommend you choosing the highest severity possible for your use case that best suits your query. So this will ensure that your case gets prioritized if it's urgent. Also, if you are an enterprise customer and have a technical account manager, they will be paged. It will be very much an all hands on deck situation. So that's something that you should avail of. And also, we really recommend, so support has internal tooling where we can check your resources and logs, but only if you have logging enabled. So if you have logging enabled, we'll be able to work much quicker, basically, to take a look at your resources and logs, and we'll be able to help narrow down the root cause and hopefully find a remediation a lot quicker.
Yeah, so carrying on from there, so in terms of the support cases that you open, along with what Louise just mentioned, right? So it's also important to add as much detail as possible into those support cases. So in terms of a DDoS attack, you want everyone to act faster. So adding as much information in terms of resource IDs, timestamps, any logs or metrics that you want us to look at, and also ensure that you're opening your support case from the account that is being impacted. So that would really help when the support engineers are reviewing that case. Additionally, customers who have Shield Advanced further benefit from leveraging a team that's dedicated for DDoS attacks. So they generally work day to day fighting against all these different DDoS events that we see. So they are called the Shield Response Team. So what you can also do is provide them access to those logs, and they'll be able to run some analysis on that to identify if there are any attack patterns. And further, they can help you create those rules within WAF and maybe look at a security groups network access list on where you can further improve to make it a more resilient architecture.
And lastly, a summary of just some of the best practices and things that we touched on in the presentation. So leveraging multiple layers of protection. This is the defense in depth method, which is best practice in terms of DDoS resiliency. So using some of the services and features that we mentioned in this will just create I guess more of a defense in depth kind of additional layers of security is what we'll be doing. So having monitoring and logging and scaling in place, we really recommend basically. And next, reduce your attack surface area by protecting internet facing resources. So another best practice is minimizing the attack surface area to limit your application's exposure to the internet. So resources that are not exposed to the internet are much more difficult to attack. And I touched on this earlier in the API Gateway slide, where API Gateway acts as a front door to secure your APIs. There's also CloudFront as well, which you can use to restrict access, and also it verifies the connections before passing any traffic to your backend. That's another thing as well. Load balancers, Route 53, are really good for distributing load as well, and ensuring that again there's just more additional layers of security in place. And also, maintaining resources in private subnets and using Bastion servers, things like that as well.
Yep. So carrying on from there, we also recommend customers to learn as much as possible about their normal traffic, during their peacetime. So by doing this, you're able to identify what are the anomalies during a particular event. So based on the things that we just spoke of, you can do this by enabling logs for VPC. You can enable WAF logs. You have CloudTrail, CloudFront logs, ALB access logs as well. You can set up alarms based on the free default metrics that we push. So not just about Shield Advanced, right? Even if you're a Shield standard customer, which you get by default, you can leverage so many of these free default metrics that we provide, and just set up CloudWatch alarms to track them. And if they cross a particular threshold, you either get notified or a page goes out to your security team so that they can take action on these. And apart from that, we also discussed about scaling your architecture. So DDoS attacks these days are fairly common. So it's how you approach these DDoS attacks and how do you set up your architecture to absorb them. So based on trends, we see these attacks consistently increasing. So we recommend customers to set up your environment to scale up. So absorb that high volume of requests. And you can do this today with Elastic Load Balancing Service or the Auto Scaling Service. And what Louise just touched upon, you have Route 53. So with Route 53, you have health checking available. So you can set up a disaster recovery setup so that all your traffic gets directed to another location, or your on-premise as well, or maybe a third-party location.
Yeah, as well as that, deploying firewalls as well for any sophisticated application attacks on layer 7. So this is really, definitely would recommend. So we have Firewall Service, which Ketan touched on earlier, to orchestrate security across all of your accounts if you have an organization or multiple accounts. And it's also good practice to use Web Application Firewall, the WAF service, against attacks such as SQL injection or cross-site scripting or cross-site request forgery as well, that attempt to exploit any vulnerability in the application itself. So due to the nature of these attacks, it's very easy to, create customized mitigations against all of these unwanted requests, and some of them could be disguised as good traffic, or coming from bad IPs. So that's why it's really helpful to use the different security features that WAF offers and customizing these rules and having rate limits in place as well. And then also, another way to mitigate this is to study the traffic as well, patterns, and creating customized protections based on those whenever you can. And lastly, creating a plan with an escalation path for attack mitigation. So this is really helpful. As I always say, just, plan for disaster, I guess. So by knowing who to contact, what alarms to set up, who to notify, are you going to have any automation in place, any auto remediation, things like that. Having a dedicated plan means that during a time of a DDoS attack or crisis, you know exactly what to do, and this saves a lot of time in the future. So yeah, that's our summary. Rob, are there any other questions from the group chat?
Hey, thanks, Luis. Yeah, so we do have one question that we just want to see if we could provide a little bit more in-depth info on. Question that came in is, are there any guidelines for how to embed the honeypot links into the sites so that users don't have to run all the scripts and not have to see the links and such? Be able to cover that a little bit more?
Yeah, I can take that one, Rob. So our documentation, I think Rob sent this earlier as well. So within that documentation, you'll be able to see some tips on how to embed them within your HTML pages. So there are certain HTML tags that you can use, right? In terms of visibility of certain links, you can turn them to false. So by doing that, a visible or a human would not actually go through your entire web page. So you generally don't find end users right-clicking and viewing the page source of your web page, but typically bots are doing these, right? So that's how you would kind of turn off the visibility of HTML links within your web page. And I think that link kind of gives you some ideas how you can approach that.
Great. Thanks, Caitlin. Thanks, Luis. So everyone, today we looked at what DDoS is and the AWS services that can help to enable you to protect your environment from them. Thank you for our moderators for posting the registration page for our upcoming episodes, AWS Supports You.splashthat.com. Please bookmark this page, and we hope you'll join us next time. If there are any questions that were not answered today, you can post your questions on forums.aws.amazon.com. Also, please feel free to email us any feedback to awssupportsyou@amazon.com. We want to hear from you. Please tell us what you would like to see on this show. Thank you for joining us at AWS Supports You. Happy cloud computing.